Good afternoon all. Uh, I'm Sirisha, working as Assistant Professor of Chemistry from Basic Science and Humanities Department, Narsarpur. And regarding course name, Engineering Chemistry. In Engineering Chemistry, we are discussing about batteries. In that batteries, today's topic is methanol oxygen fuel cell. As we know that, what is meant by fuel cell? So, fuel cell is nothing but which is a electrochemical cell, whereas the chemical energy will be converted in form of electrical energy by undergoing combustion process. So this is methanol oxygen fuel cell is also one of the fuel cells, whereas which is acts as an electrochemical cell, whereas the chemical energy will be converted into electrical energy by undergoing combustion. What is meant by combustion? Burning of fuels in presence of oxygen is called as combustion. So, at the time of combustion, if it converts chemical energy to electrical energy, that cells are called as fuel cells. So, in methanol oxygen fuel cells also one of the fuel cell. So, in the present class, we discussed about methanol oxygen fuel cell. So, as a methanol oxygen fuel cell, which is one of the electrochemical cell, which convert chemical energy into electrical energy by undergoing combustion process. So, in earlier class, we discussed about H2O2 fuel cell. So in present class, as usual, in place of hydrogen, we can take the methanol as a oxidant, fuel oxidant. So here we discussed about methanol oxygen fuel cell. So methanol oxygen fuel cell is also called as DMFC, direct methanol fuel cell, which is called as direct methanol fuel cell. So DMFC utilizes methanol as fuel and oxygen from the air to generate electricity. So, here we are taking methanol and oxygen from the environment, air, which generate electricity. So, which offers high energy density and refueling convenience, making a suitable portable power applications, which is used for the power applications. Different types of power applications, we use methanol oxygen fuel cells. So here fuel supply, nothing but here we are supplying the methanol is supplied to the fuel cell to the anode. So anode is nothing but which is a negative electron, which is represented with negative, right? So anode, through anode we are supplying the methanol gas. So when we passes the methanol gas from the small tank of cartridge. So nothing but small tank of cartridge means you can observe the diagram here. So in this diagram, you can see two different, that means the direct methanol oxygen fuel cell. So here in this tank, we are passing the methanol plus water, some amount of water we are passing. So when we pass this one, which releases CO2, right? So one side we are passing methanol. So this methanol here at anode, which is nothing but having the negative terminal, here the methanol will convert into CO2. And in opposite side, we are passing H2O again because as we know that the oxygen is passed through outside, nothing but from air. From air, the oxygen which is there, the oxygen is passed in opposite direction. So that oxygen again react with the liberated electrons and water molecule left over, which forms the again more amount of H2O molecules. The liberation of H2O molecules will takes place here. So come to the first one. See this one. Anode is nothing but methanol, which undergoes electrochemical oxidation. So that means what is meant by oxidation? Oxidation is nothing but liberation of electrons. So what is the reaction takes place there here? So here it is not balanced. See, 3 moles of nothing but 2 plus 4. So here the 6 moles of H plus ions are liberated and 6 electrons are liberated here. So if you take this reaction, methanol react with water molecule, so which release CO2 plus H plus ions, some amount of electrons. So that means CH3OH, when it react with H2O, what happens here? When CH3OH react with H2O, which forms CO2 plus H plus ions and 6 electrons are liberated. So liberation of electrons is called as oxidation. So at anode, which reaction takes place here? Oxidation reaction takes place. And come to the electrolyte. Here the protons which are not there, which are there, H plus ions generated at anode. So at anode, what are the ions generated here? H plus ions. So that are nothing but protons. So move through the polymer electrolyte membrane. Nothing but here what is the electrolyte we are taking? Electrolyte membrane we are taking, and which pass towards the cathode. Cathode which represent with positive electrode. So positive electrode. So here the polymer membrane nothing but which allows the protons transport while preventing the fuel oxidation gas mixing. Nothing but the oxygen gas will be mixed with the protons and which liberate H2O. So that means the oxygen gas passes through cathode. So from cathode, that oxygen gas and the H plus ions liberated at anode and the electrons also liberated at anode. These are undergoing reaction which produces H2O. Nothing but the amount of oxygen which is there, that O2, plus amount of H plus ions liberated plus electrons liberated, 6 electrons. So which forms, what it forms? Which forms 3H2O. So 3H2O is liberated here. So these are the overall reactions are takes place. So come to the cell representation. Here if you observe the cell, see this one, see the cell clearly. So this side, this is the anode and this is the cathode. So this is the cathode, right? So at anode, what we are passing? We are passing methanol gas. So what happens this methanol gas? So this methanol gas react with H2O, which is there in the reaction. So which is undergoes the reaction with H2O and liberates CO2 plus 6 moles of H plus ions plus 6 electrons. So which releases protons as well as electrons. So the liberated electrons, what happens at cathode? This is the anode, right? So what is meant by oxidation? Liberation of electrons. So at anode, what is the reaction takes place? Oxidation takes place. And at cathode, what happens? At cathode, what are the, which gas we are passing? We are passing oxygen gas, right? So we are passing O2 gas. And the liberated protons are there here, 6H plus ions. And the liberated electrons are there. So that 6 electrons, which forms 3 moles of OH minus ions. Now if you see the overall reaction, what is the overall reaction we get? See the overall reaction. So the overall reaction is CH3OH react with H2O again here. Some amount of 3 moles of O2, 3 by 2 O2. So these 6 electrons get cancelled because both are in opposite side. 6H plus ions, 6H plus ions and 6 electrons both are get cancelled. So what it produces? It produces CO2 plus 3 moles of OH minus ions and some amount of energy. So it releases some amount of energy also. So this is the overall reaction takes place at anode and cathode. Come to the next, electrical output. When the oxidation and reduction takes place. So what is the output we get? See that one. The flow of electrons from anode to cathode throughout the external circuit. That means through the external circuit. Here if you see this one, there is a load, right? So from the external circuit, if you observe this diagram also. So from the load here, from the external circuit, the electrons are transferred from anode to cathode. Next case about the waste production. So if the reaction takes place, when the chemical reactions are takes place, that means here we know that oxidation and reduction both are takes place. At anode oxidation takes place and at cathode reduction takes place. So at the time of oxidation and reduction reactions, the only byproduct which is nothing but CO2 and some amount of water. It releases CO2, carbon dioxide and some amount of water as a byproduct we get, and which are environmentally friendly compared to the pollutants emitted which are non-toxic compared with other pollutants, little bit better than other pollutants based on power sources. Next come to the advantages of methanol fuel cell which is having so many advantages are there. So in that one, which is used as a high energy density batteries, and quick refueling capacity which is having, and ability to store the methanol in form of liquid. So mostly the methanol is stored in form of liquid, and which is used in most of the applications, laptops, mobile phones and electrical vehicles. However, these are used in NACAR vehicles. So we know that NACAR vehicles, right? NACAR vehicles. So in that NACAR vehicles also we can use this fuel cells. So this is regarding. So overview. Come to the cost also. The durability and cost is also compared with other fuel cells. This is somewhat better. Come to the limitations. Whereas the limitations, these fuel cells lifetime we can't measure it. Same as usual for the H2O2 fuel cell also. The lifetime we can't measure it. So here also we can't measure the lifetime of these fuel cells. And it produces the energy 1.21 volts of energy. So if you take the H2O2 fuel cell which produces 1.23 volts of energy, and if you see this one methanol oxygen fuel cells which produces 1.21 electron volts of energy. So volts of energy which produces. So this is about the methanol oxygen fuel cells. So come to the methanol, the basic few points about the methanol oxygen fuel cell. So methanol oxygen fuel cell is also one of the fuel cell which acts as electrochemical cell, which is a electrochemical cell. The main point is electrochemical cell. Here which convert chemical energy into electrical energy by undergoing combustion process. So here the combustion process takes place. So by undergoing combustion process, the chemical energy will be converted into electrical energy. So see the methanol oxygen fuel cell. Here anode and cathode both are there. So anode is represented with negative electrode and cathode with positive electrode. So at anode oxidation takes place. So see the anodic reaction. The methanol which is there react with the H2O and liberate CO2 and proton and electrons. So which liberates the electrons which is called as oxidation. So at anode oxidation takes place. Come to the second one about the cathode. So here we are taking the electrolyte membrane. Nothing but we are taking membrane to pass the electrons from anode to cathode and cathode to anode, right? So here that through the membrane, the H plus ions which are there, that will be transported to the cathode, and not only that, the O2 is passed from outside. So the H plus ions and O2, which is nothing but the O2, and the H plus ions liberated at anode and the electrons liberated at anode. So these electrons are gained at cathode. So reduction takes place and it releases some amount of water molecule and some amount of energy. So definitely if oxidation and reduction both are takes place, it liberates some amount of energy. So these are the anodic and cathodic reactions which are takes place. And here come to this one, the overall output is nothing but here anode is at anode methanol undergoes oxidation. At cathode the O2 molecules gain the H plus ions and electrons undergoes reduction, and the electrons are transferred from anode to cathode externally by external circuit. So through external circuit electron transfer also takes place, and by undergoing these reactions which release some amount of energy. So next come to the byproducts. What are the byproducts formed? Here see the byproducts. Water is as a byproduct it forms, and not only that, the CO2 which is formed. So when the undergoing combustion process, it releases some amount of CO2 also. So these are the overall reactions takes place at methanol oxygen fuel cell. And come to the advantages of methanol oxygen fuel cells. So which is high density, as I said, having high density energy, high energy density and ability to store more energy, and these are used in laptop, mobile phones and car vehicles also. So these are the applications of methanol oxygen fuel cell, and not only that, which store the energy 1.21 volts of energy. So these are nothing but, well, at the time of installation cost is high, and not only that, we can't assume the lifetime of these fuel cells. So this is regarding methanol oxygen fuel cells. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.